So I lied. I had one more example written out for you using dot products. This will be our final video in the 11.3 section for our calculus videos on dot product. This is an example from physics. We're going to do one from work. Later on, we'll do magnetic flux. But work is force times distance, the work done by a constant force and moving an object a distance d. Okay. So let's say we're dragging a box or pushing the box, doesn't matter how we do it, push or pull. We're pushing a box from that A to B. The work is going to be the dot product of those. These two have an angle of 0. Cosine 0 is 1. So work in this case is just force times, or the magnitude of the force times the magnitude of AB. If force is 6 units or 6 newtons of force and the distance is 8 meters, the work is 48 Newton meters, which is 48 joules. Okay. So what if it's on a wagon? We're pulling it along a wagon. And the wagon handle makes an angle theta with the ground. F is up at the angle. Well, for this picture, we'll do 45 degrees. We can figure out F1 by doing our norm times cosine theta, which is 6 newtons times root 2 over 2, cosine of 45 degrees. So we get through root 2 newtons. So then if we're doing that now, F1's in the same direction. Cosine of theta is 1. We've got F1 times AB is through root 2 times 8 meters. We get 24 root 2 Newton meters or 33.94 joules. Another way of doing this is doing, well, this really. We've got work equals force times distance, which is the magnitude of the force times the magnitude of the distance times the cosine and the angle between them. The force was 6 newtons, the distance was 8 meters, and the angle was 45 degrees. And when you work that out, you'll get this as well. So this was leaving it with the handle up and using the dot product as is. Switching to that formula. This is refinding the component of F in the direction of AB. So we use our directional angles to do that. And a couple ways to get it. That's it for 11.3 dot product. Peace out.